So now let's move into overall discussion. So there are likely some unanswered questions in the chat. And yeah, if we can open it up. So anyone who has questions for any of our speakers, if our speakers have questions for each other, now is a good time to speak up. Either unmute yourself. If someone is talking already, you can use the raise hand feature under reactions, or feel free to type things into the chat box. So yeah, here, we'll open it up. Oh, I see Jacob's hand is raised. Go ahead, Jacob.
I don't really have a question, but I was wondering, well, maybe it is a question. I was wondering if maybe we could go back to Kayla, who got a question earlier about what analogs she would like to see next on the solar system website.
Sure, yeah, thanks, Jacob. So Nick asked a really exciting to me question in the chat, which was, are there specific analogs not on the site that we're looking for or we'd like to highlight? And the answer to that is absolutely yes. Right now we have a lot of coverage of the moon and coverage of Mars. That's all good stuff. We don't want to not have that. And we also have a little bit of coverage of some other locations, including ocean worlds and Venus. But certainly as we continue to develop content and expand this resource a little bit further, I would love to see that coverage kind of round out and continue to expand. So thanks to Nick and Catherine, who already are making some connections in the chat, and thanks for that question. And it looks like Jennifer Heldman has a hand up.
Hi, yeah, this was a great session. So since Greg Schmidt is on, at least I see his name listed here, we thought maybe we could just have a conversation based on Darlene's talk, because, you know, as evidenced by the thoroughness of, you know, the safety plans and the codes of conduct and the pre, during, post deployment and all of the safety and the logistics. And so, you know, Darlene has been thinking about EDI before it became in vogue, so to speak, right? So I think that she's ahead of the curve on a lot of things. And this might be an area of real survey leadership, of bringing, you know, the EDIA into the field work. And it might be, I'm just thinking out loud of, like, you know, a high level survey managed activity, because there are different teams that do field work, but to really integrate this process and really take advantage of, you know, the decades, 2 decades plus of work that's been done, you know, across survey teams and across the community, and with USGS, and like there's a lot of partners to bring in. And so I just wanted to maybe just have a discussion about how we go about doing that, and bringing the thoroughness that's been put forward, you know, to other teams and groups and whatnot.
Well, Jen, it's interesting that you mentioned that. First of all, I love the idea. And it's funny, we must have had a telepathic link, because I sent a private message to Darlene just before you got on to say that we ought to think about fashioning what she put down into guidelines for us that we can then, you know, extend to the community potentially. So I absolutely love your idea, and let's move forward with it, perhaps through the analog focus group that you and she and Tim run, or maybe some other way. Love it.
Yeah, it sounds good. And I guess I should ask Darlene, since I kind of put her on the spot too.
So it sounds great. I just saw the your chat to me, Greg, and absolutely. And then Joe asked if there is a best practices or standards for developing analog test site procedures and safety plans. You know, Joe, so what I shared very rapidly I feel like, I don't know if you guys seen Toy Story, but the pig, when he watches TV, it just goes at, rapid pace. It felt like that today. There's a lot that we can share, but I want to make sure that, again, I stress and underscore the word and highlight the word considerations, because every time I have a conversation, as we just recently did, as enabled by Elise and Lauren at USGS, the community has so many wonderful ideas. There's so many thoughts about, say if they've come from a military background, there are, again, there's process and protocol and methods for moving towards a safe and accountable environment. And so beyond what we've done, this is what we do. This is our baseline. This is what we think about when we move forward. And we know through experience, it's pretty good, but there's a lot, we can get to a much better place real fast. And, we have to find a way to make sure that we open up this conversation and learn from the community at large. But indeed, we're very happy to put forward what we have as a again, a consideration or a use case that people can take and tweak and make better, because that's really what we hope will happen, is we'll evolve.
Yeah, that sounds great. Let's move forward. What a wonderful idea.
Yeah, I really like that idea too. I think it's great. Maybe it's something in the, I don't know if everyone's aware, but there's a survey EDI group that meets every other Friday. And so this could be a good discussion in that space. And perhaps that's a good space too, to figure out the next steps. Because yeah, we don't want to let this fall off our radar.
Great idea, Elise. Let's do it.
All right. Sounds good.
So we could have a joint EDI analogs focus group meeting to cover this topic.
Wow.
Wow. Yeah.
Okay, this just keeps on getting better.
Sorry, I was inspired by Elise's idea.
Yeah.
Yep. Love it. We'll make it happen. Let's do that.
Yeah, I think that's a really good idea. Keep this conversation moving. I think there's so many good ideas, and yeah, we don't want to lose them. So cool.
Have fun. Thank you.
Yeah, thank you, everyone. All right. So I see a question in the chat for myself from Sarah. She writes, what do you recommend as a starting point for teams of non-data scientists who are looking at reworking their field analog data to be compatible with the USGS analog site? And that is a really good question. And what this lies in, as I spoke about, is the metadata. So above here, somewhere, I can put it in again, the link to our web page. And if you click on that main link and go over to how to contribute, there are some very good first steps in going through there and looking at our data requirements. And there's also, so there's metadata requirements. So essentially what it would be is making sure that you can create the metadata for your data so that it'll fit into the data portal. So if you go to that link, go over to how to contribute. One of the cool things about ScienceBase is that it has a metadata wizard. And as I'm saying this, I'm realizing that might be a tool that's only available to USGS folks. But I can look into that, or folks can try to click on the link and see if it works for them. But yeah, so I think that would be the main step, is looking at our metadata requirements. And if you can't, it's totally, if it's not perfectly clear on the website, because like I said, this is a first draft of this website. And so we want to make sure that it is accessible to everyone and readable by everyone. So if the metadata standards aren't clear on the website, email me. Mark Hunter is the other main contact for the data portal. So contact either of us and we can definitely work with you to help make your data work for our data portal. This is very much a work in progress. And so at this point, yeah, we are looking for contributions, and we're asking, these first few people that contribute, the first few data sets are really going to be test cases with working together to figure out the best way to do this, because we do want to create something that is easy for the community to use and access. Yeah, so thank you for that question.
I'll jump in and just read out an exchange that happened earlier in the chat as well, in case anyone is not accessing the chat. Joe Manafra asks Ben, is CODA available for the public? And then Feist replies, could be available to the public, but the data it visualizes hasn't gone through export control. So for more info about that, I'll open it up to Ben if you'd like to add anything there.
Yeah, thanks. CODA is currently inside NASA, and it's using data that is inside NASA. And NASA has a process called export control, where we make sure that before any information is ever released to the public, that we know that it can be released to the public forever. There is a pipeline for, I believe, Public Affairs Office, where they can do that. You know, you can watch on YouTube a live stream of NASA TV during an EVA, and that's clearly a real-time export that's happening. So once we do get all the planetary data gathered in a way that can be visualized with software, which is our current step, as soon as the public engagement conversation starts, we'll be ready to just flip the switch and have real-time information available to the public if we can create those pipelines for export. Sorry for the long lesson about how NASA works with data, but that's why CODA is currently not outside the NASA firewall.
All right, thank you, Ben and Joe. I'll add another question to the mix here that came to mind during Sarah's talk, but actually I think it's relevant to a few of our speakers today. So maybe we can open it up a little bit. I'm curious as to, in the process of trying to get all of this incoming data into a structure and a format that's more accessible and available to more researchers, how much do you see that happening retroactively? And are there totally different challenges on that front?
I zoned out for a second. Can you repeat your question, Kayla?
Sure. Just curious hearing from you and from Sarah, and I think this kind of connects even out a little further too, about trying to get planetary analog research data together into a form that is more easily used by more people. And I apologize if this was implied and I missed it, but is archiving data retroactively a major part of that plan, or is this mostly looking towards future data collection?
Cool. Yeah, that is a really good question, and I think it's like fundamental to a lot of the things some of us talked about. So with our data portal, yeah, we would be willing, we're happy to accept data that's been collected previously and new data. And in facilitating collection of new data, we'd love to help, you know, when we talked about, when we talked about coming up with README files and those sorts of things, you know, right now those are internal to geodes and GIF teams, but we think, you know, making something like that more publicly available and shared so that folks know and are aware of, you know, of all the things to be paying attention to and recording before, during, and after field work, because, you know, we all have so many things going on that it's easy to overlook some things without realizing it. So yes, we're definitely supportive of contributing new data and old data, and also connecting to databases that already exist, because a lot of universities have repositories that are, and NASA has repositories that are good and are clear. And so connecting to those so that we don't have to completely redigest everything would be really helpful. And then there was a second part to your question about oh, community, getting the community to all use it. Yeah, and that is a bigger question, and Sarah might have more to say on that end. But yeah, because I know people, you know, if repositories already exist, then that's great. And what I think is really helpful is having a data portal like ours, where it can search all those repositories and it is one place to go to and is known as a place to go for the community to use. I'm not saying USGS has to fill that role. I'm saying that we are capable of filling that role, and we've filled that roles in other aspects of planetary science. And so, yeah, I think that is a question for the community. What is it that we can help with, or that some NASA or some other entity can help with to facilitate this kind of community gathering and making a site that people want to use and that people will use? You know, that's a question we have too for the community. I don't know if anybody has other comments on that. I'd love to hear them.
I'll read one out from Sarah in the chat, and thanks for that response to Elise. Sarah adds, in the case of, I might butcher this acronym, do you pronounce it ARADS? I would say the majority of it is retroactive, as the depth log / sample creation are very dependent on the function of the full sequence of operations in the field. And we find ourselves merging the manually collected notes as the user-friendly spreadsheet timeline record of drilling and sampling progress. Thanks, Sarah. And I don't know if you're able to unmute. Feel free to jump in if you'd like to add on more to that, or we can keep communicating from the chat as well.
Hi, it's Darlene. I have a comment, but I wanted to raise my hand, but for some reason my Zoom is not enabling me to do so. I apologize. I don't know if somebody else wants to go ahead of me. No? Okay. I just have a, it's not really a solution or anything, but it's a couple of comments around some things that we run into on our team. So we find that in terms of data sharing, you know, the number one action that we'll try and take is to publish. We'll publish, you know, tables of data, as much raw data as we feel comfortable, as much as the publication in a journal will feel is okay for them to put out there as well. But then after that, you know, you kind of get by the hair of your chinny chin chin once you've got just enough money to kind of get people to the end of that publication realm, and then that's it. Then you're sort of at a cliff at that point in time. Having the bandwidth to then make sure that the data is archived somewhere which is accessible to the community and so forth. Like if we're in a flight mission scenario, for example, there would be budget set aside allocated for that particular act to make sure that there was compatibility, to make sure that there was accessibility and so forth. We don't have that in our budgets. Or at least we don't have it in the budgets that I've been working with when it comes to analog missions. And so that may be something as a community that we feel strongly we want to make sure that there is a repository, a centralized repository, that we somehow ask for that we put that forward as a need in future funding calls or something to that effect. Because I can certainly tell you that our reality is that once you get that acceptance, you're like, phew, okay, I'm done. I did what was expected of me in terms of getting my data and my findings out there into perpetuity, and that checks all sorts of boxes, including archiving from a research perspective. So not a solution, but just a consideration that we'd love to find a mechanism to be better able to do archiving for sure. Okay, that's it.
Yeah, I absolutely agree, Darlene. And I don't know the perfect solution yet, but I agree that it should somehow be integrated into the proposal process, so that maybe providing some sort of training for folks, and in calls for proposals, including language to let people know that they about archiving requirements, and that they should include funding for the time it takes to archive. I don't think it's something we can implement right away, and I don't know. I don't work for NASA. I don't know on that side about more kind of requirements and how there could be accountability for folks. But yeah, I think that's a conversation that's important to be having, and that we should keep in mind. And yeah, hopefully the community can move forward on that. Well, I have a question for Ben. So Ben, I really liked your presentation and talking about kind of recording everything for basically, for science, but also for the historical value of things. And the examples you gave were kind of larger field campaigns or larger campaigns with either, survey teams, or at the Neutral Buoyancy Lab, there's a lot of people involved. Do you have any advice for maybe small teams or low budget teams, how they can best record things for kind of in the manner you've described?
Sure, that's a great question. It's I guess if everybody internalizes the idea of that your data might be more useful than what you think you're going to use it for, and what could you do to make sure that it, as you put the photos in the shoebox, as it were, you organize them in some way for someone else. Because one thing we've seen in Apollo, and even in the field training they did on Apollo, that material and footage and stuff that you saw in Noah's presentation this morning, we wouldn't have anticipated that we needed to find things out that we do from it. So one way to do it is to just make sure that when you're gathering your data, you are putting it somewhere permanent residence. I think often, like for something like a PDART, that you can even just use GitHub for that. Someplace where it's accessible to people, it's documented a little bit, doesn't have to be super documented. And often it's going to be whatever comes off the instrument. And unless you're really interested in moving up those data levels that I introduced, you could just keep them as what they are. And as long as they're all cataloged, that's going to be really valuable to somebody in the future. If you wanted to go one step further, you could go to Good Measure to make sure that all the clocks on different instruments are all synchronized and set correctly. For example, on the first Rise analog, none of the GoPro's clocks, well, I mean, a GoPro resets to like 2013 every time you change the battery. So it's a real pain to set the clock properly. So, and but maybe you take that 30 seconds before you run the video footage to make sure it's the current time of day. That actually can be really useful later on. So anyway, I could carry on about things like that, but any little thing you can do, and this is like the same, the lesson is, early requirements into a mission to say, hey, could you just gather the data in this particular way? It doesn't add much scope to what needs to be built into a mission, but doing it after you've collected all the data and you realize you haven't done it in a certain way takes a huge amount of effort to try to reconcile the problem after it has been caused. So just keep your eye on that, and I think you could go a long way.
Cool. Yeah. Thanks for that. Yeah. Sometimes it's tough because you don't know. I don't know what to phrase that's right. You don't know what you don't know until you don't know it. So yeah,
Right.
You don't always know what's going to be the most useful, but yeah, some of those are really good considerations to keep in mind. Thanks. Noah, you've got your hand up. Go ahead.
Yeah, I just wanted to piggyback on something Ben said that I learned from Ben Feist in the field. Is there's a free app, at least for the iPhone, called Time, that lets you have time at the 10th of second scale. And if you just take a picture with your field camera of that and take hold that up in the field of view of your camera, that becomes a moment that is captured. You can synchronize. You say, I know that I took that picture. You can calculate the clock drift. If your GoPro resets to 2013, well, you know that you just photographed that clock at July 21st, 2021 at 4:26 p.m. Eastern. And you see, well, the metadata says this, but I know the reality is this. There's a 3-year, 10-week, 2-hour, and 10-second delay between the two. That lets you, by brute force at least, correct those things. I've learned that from Ben Feist.
That's what a great lesson to be able to teach Noah Petro.
Now, if someone could come up with a mechanism to take a picture of like a QR code that would automatically synchronize that, I think you should work on that, Ben.
Yeah. Thanks. Thanks for teeing me up. We actually have baked a time sync into a QR code. So you can, here, I can show it on my phone if I can do it quickly. But basically it's a QR code that shows, let's see, I'm not going to be able to do it quickly. A QR code that changes once a second that shows what the current time is. And if you show it to a video the way Noah just talked about, you can write automated software that looks frame by frame for those QR codes, and then it can calculate what the start time of each video is. And we've actually done this on ISS because they have the same GoPro that resets to 2013, and we don't want to spend crew time setting the clock on the GoPro. So we just beamed up an iPad application that has that QR code, and it was part of their operations before they went on EBA. They start the GoPro and they film the QR code. And what that gives you is, the GoPros record the video with a timestamp in the actual file, and that timestamp's wrong. And then every subsequent time you hit start and stop on the GoPro, it creates a new file that all have incorrect timestamps. But if you have one video that has this corrective QR code in it, you can figure out what that differential is and apply it to every video. And suddenly all the footage they shot outside, including their still camera that they used on EVA, was all synchronized exactly. So this is all just towards what can we do that's a light touch without having to go in and reinvent systems that are already on orbit. But if you are inventing the new system, like for Artemis, you would just write in a little requirement that says the clock needs to be correct. And the engineers will figure out a better way than hacking together a QR code to do that. But if you're using existing systems, there are ways that you can do that. So anyway, thanks, Noah, for being my agent.
Yeah, that's a really great reminder. I know I've definitely looked at images and videos and realized I have no idea what time zone the camera was set for when I took those. So yeah, definitely.
Yeah, and it's little things like that that can trip you up for a long time if you haven't thought about it beforehand.
Yeah, and I've also noticed in sharing. So I know in some instances I've shared things with colleagues on Google Drive, and Google Drive wipes away a lot of the metadata. And so if you have if you have a QR code or a picture of the time, then it doesn't matter if the metadata is gone. I mean, you lose location data too, but at least there's a saver in there. So cool, thank you for that.
Yeah, I think that there might be a common theme that and I don't know if it's common, but I've seen on analogs that you spend so much energy getting to the field, you're shipping instruments, you're finally there, you're doing the thing, and you're getting exactly what you thought you wanted. That then to know that there's another third of work that happens after you've come back to do this other stuff. I don't know if that's ever on the schedule. I mean, people get busy, the budget isn't there maybe. But I think if you just recognize that the whole thing is all that planning that has to go into it, like we just talked about, safety procedures and things like that, and training that has to happen before you get into the field, equal on the other side when you come out of the field.
Yeah, absolutely. That is something that we look over a lot. So yeah, continuing this conversation so that we all try to keep that in mind when we're planning and writing proposals and those things is key for this.
Real quick, this is Brian Day with Servia. And with regards to the timing issue that has been discussed, in cases where you do need very precise timing, we can learn from the astronomical community, which uses video cameras for occultation timing, as well as the group that is doing recordings of meteoroid impact flashes on the moon, where tiny fractions of a second make a difference. And they have standard equipment to pull in GPS time signal and embed them in the video train. And so that is existing technology that in cases where you do have a need for precise timing, we can learn from them.
Yeah, that's a great example of knowing you need it and making sure it's part of the process. I agree.
It looks like this discussion has taken us already almost to the end of our scheduled time for this session. So are there any final questions or comments that folks would like to raise before we get ready to wrap it up here?
Kayla, I just want to say thanks to everyone. Thanks to you and Elise and everyone for just a fabulous session. It's really great.
Thanks, Greg and Mike, for all the work behind the scenes. Much appreciated.
Yeah, definitely. Thank you to everybody and to all of our speakers. It all went, minor hiccups, but otherwise it went really well. Yeah.